Hello, 6th graders. Welcome to Big Ideas Math, Section 10.5, Independent and Dependent Events lesson. Pause while you copy the lesson title and number into your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is students will use a formal definition to compute theoretical probabilities of independent events and dependent events. Copy the following term and definition into your notebook exactly as it appears. Compound events may be independent events or dependent events. Events are independent events if the occurrence of one event does not affect the likelihood that the other events will occur. Copy this key idea into your notebook. The probability of two or more independent events is the probability of the events. So the probability of A and B equals the probability of A times B, times the probability of B. And the probability of A and B and C equals the probability of A times the probability of B times the probability of C. Example 1, finding the probability of independent events. You spin the spinner and flip the coin. What is the probability of spinning a prime number and flipping tails? The outcome of spinning the spinner does not affect the outcome of flipping the coin. So the events are independent. So the probability of prime equals 3 over 5 because there are 3 prime numbers, 2, 3, and 5 on the spinner. Get that straightened out there. There we go. And there are a total of 5 numbers on the spinner. And the probability of tails, there is one tails side. So the probability of tails is 1 out of 2 because there are a total of 2 sides. Use the formula for the probability of independent events. So the probability of A times the probability of B. So that's what you just wrote down from the last slide. So the probability of prime and tails equals the probability of prime times the probability of tails. So 3/5 times 1/2 equals 3/10. So the probability of spinning a prime number and flipping tails is 3/10 or 30%. Now copy this following term and definition into your notebook exactly as it appears. Events are dependent events if the occurrence of one event does affect the likelihood that the other event will occur. And then copy this key idea into your notebook, the probability of dependent events. The probability of two dependent events, A and B, is the probability of A times the probability of B after A occurs. So probability of A and B equals the probability of B times the probability of B after A. So that's a little bit trickier than the last one. So our next example is finding the probability of dependent events. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So once somebody is chosen, they aren't going to be chosen again, so that's why this is a dependent event. So choosing an audience member changes the number of audience members left. So the events are dependent. So probability of a relative is 5 out of 100. So there are 5 relatives. And if we simplify that, it's 1/20th. And then, so because there are a total of 100 audience members. And the probability of a friend, so remember this is the probability after your relative is chosen because that's the question. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So there's 6 friends And so once one of your relatives has been chosen, then there's only 99 people left in the audience. So there's 6 friends out of 99, total of 99 audience members left. So 6 out of 99 reduces to 2 out of 33. So we use the formula for the probability of dependent events. So the probability of relative and friend equals the probability of relative times the probability of friend after relative, which is what we just figured out up here. So 1/20th times 2/33 equals 1/330th. So the probability is approximately 1/330, or about 0.3%. So example 3, bear with the small writing on the slide. I apologize, but it's a lot of stuff on this one. Find the probability of a compound event. So a student randomly guesses the answer for each multiple choice question. What is the probability of answering all 3 questions correctly? So I know some of us try this on multiple choice tests, and it's not always the best studying technique. So in what year did the United States gain independence from Britain? So there are 5 answers to each question, and there's 2 other questions there as well. Choosing the answer for one question does not affect the choice for the other questions, so the events are independent. Method 1, use the formula for the probability of independent events. So the probability of number 1 being correct times the probability of number 2 being correct times the probability of number 3 being correct. So each question you have a 1 out of 5 chance of getting correct. So 1/5 times 1/5 times 1/5 equals 1/125, which once you simplify everything, it comes out to 0.8%. Method 2, you can use the fundamental counting principle. There are 5 choices for each question. So there are 5 times 5 times 5, which equals 125 possible outcomes. There's only one way to answer all 3 questions correctly. So the probability of number 1, number 2, and number 3 being correct is 1 out of 125. The probability of answering all 3 questions correctly is 1 out of 125, or 0.8%. So 2 different methods to solve the same problem. Remember, to be finished with this flipped lesson, you need to have all of your notes, your vocabulary, and any other work that was assigned for the flipped lesson completed, as well as any questions you have. And as always, have a good attitude.